the consumption function with A is equals to 200 and MPC is equal to 0.5 that we have read earlier can be written as C is equal to 200 plus 0.5 Y. Given that planned investment spending is $300 billion. The aggregate demand function Y, AD, is equal to C plus I is the vertical sum of the consumption function line, that is, C is equal to 200 plus 0.5 Y, and planned investment spending, that is, I is equal to 300. Aggregate demand can then be expressed as C is equal to 200 plus 0.5 Y plus 300. The point at which the aggregate demand function crosses the 45-degree line, Y is equal to YAD, indicates the equilibrium level of aggregate demand and aggregate output. In figure, equilibrium occurs at point J, with both aggregate output Y star and aggregate demand YAD star at $1,000 billion. This equation, plotted in figure, represents the quantity of aggregate demand at any given level of aggregate output and is called the aggregate demand function. You might ask one very elementary question: why economy will stay at equilibrium? Why aggregate demand will always tends to meet aggregate supply? To see whether the economy heads towards the equilibrium output level of $1,000 billion, first let's look at what happens if the amount of output produced in the economy is $1,200 billion and is, therefore, above the equilibrium level. At this level of output, aggregate demand is $1,100 billion. That is, point K, $100 billion less than the $1,200 billion of output, that is, point L on the 45 degrees line. Since output exceeds aggregate demand by $100 billion, firms are saddled with $100 billion of unsold inventory. To keep from accumulating unsold goods, firms will cut production as long as it is above the equilibrium level. Output will exceed aggregate demand and firms will cut production, sending aggregate output toward the equilibrium level. What happens if aggregate output is below the equilibrium level of output? Let us say output is $800 billion. At this level of output, aggregate demand at point I is $900 billion. $100 billion higher than output, that is, point H on the 45 degrees line. At this level, firms are selling $100 billion more goods than they are producing, so inventory falls below the desired level. The negative unplanned inventory investment will induce firms to increase their production in order to raise inventory to desired levels. Now that we understand the equilibrium aggregate output is determined by the position of the aggregate demand function, we can examine how different factors shift the aggregate demand function and consequently change aggregate output. We will see that either a rise in planned investment spending, that is, decisions of people like Mr. Karthik, or a rise in autonomous consumer expenditure, that is, decisions of people like Mr. Shashank, shifts the aggregate demand function upward or downwards and leads to an increase or decrease in aggregate output. Suppose that a new electric motor is invented that makes all factory machines 3 times more efficient, because firms are suddenly more optimistic about the profitability of investing in new machines that use this new motor. Planned investment spending increases by $100 billion from an initial level of I1 is equal to $300 billion to I2 is equal to $400 billion. What effect does this have on output? The effects of this increase in planned investment spending are analyzed using a Keynesian cross diagram. Initially, when planned investment spending I1 is $300 billion, the aggregate demand function is Y1 AD, and equilibrium occurs at point 1, where output is $1,000 billion. The $100 billion increase in planned investment spending adds directly to aggregate demand and shifts the aggregate demand function upward to Y2 AD. Aggregate demand now equals output at the intersection of Y2 AD with the 45-degree line Y is equal to YAD. As a result of the $100 billion increase in planned investment spending, equilibrium output rises by $200 billion to $1,200 billion, that is Y2. For every dollar increase in planned investment spending, aggregate output has increased twofold.